So we're going to start the next session on GitHub and Git. Okay, great. Thank you for listening to the command line. That's why it's called a command line, you know? Okay. So today we're going to talk about Git, and the best way to do it is to actually use it. I need to find the slides, so I'm going to do that. There we go. One was from Google. The day before we had Winston's, and now I'm going to pretend to be yet another person out there. His name is Lawrence Putra. He's one of our mentors. He's originally from PayPal now, and he happens to be Jost's boss. So Jost, if you took his tutorial in the morning on Ruby on Rails, Jost works for Lawrence at PayPal. Let's see whether I can get this to work. This is not good. A lot of things are not working today. Okay. All right. So my name is Lawrence Putra. I'm Min. And you can find these slides here. You can just click the link and go there and get them. This is actually HTML. If you didn't notice any better, you can see right here, this is document type HTML. It just happens to have quite a lot of JavaScript attached to it that allow it to look like a presentation. So it can be navigated with slides, with, arrow buttons. Okay, so as I already mentioned to you, he is previously an engineer at Builpin, then later at PayPal. And he is an organizer. I don't know whether he's still organizing Git Camp, but he was in past years. Okay, he has a lot of experience with Git, and I think all of you will too. It's not hard to get 3 years of experience with this tool as we go along. Okay, what will you be learning today? What Git can do for you? How do you fit it in with your workflow? And hopefully a live exercise with Git. I'm not going to do too much with it on live, but we're going to try to make a repository and do some work on it. Okay, so what is Git? Okay, Git is like a checkpoint system in computer games. So when you play a game, after you get to a certain point, you get a checkpoint, you clear it, and then you don't have to restart from that point when you mess up, right? You don't have to start over again. So that's exactly what the technical name is for, the informal name for version control, all right? So version control is a little bit like a backup, but not the same at all. Basically, what it means is that you save the state of something that you're doing, and you allow yourself to restart from there, or you allow someone else to pick up from that spot. Okay? And so you want to, as you think about delivering your product, as I talked to you about Agile yesterday, okay, is to have some stops along the way where you are checking things in when they start to work. Okay? So when you do something really stupid, and this happens a lot, not saying to you, but to me too, okay, you can go back in time, right? Like time capsule or any backup system, and restore the state of your program. Okay? So you don't have to go figure out, oh, you know, I deleted that line and that's why everything crashed. Now, a lot of you, maybe in your CS 1010 experience, when you are writing your program, you have file names a little bit like this. version 1.0, version 1.1, version 2.2, version 2.0 submitted to Ivy League, version 2.2 submitted to Ivy League final, version 2.2 submitted to Ivy League final, really final, okay? So if you do that, that's a sign that you could really use version control. You have a compulsive problem of renaming your files, okay? So Dropbox is another thing that people think, oh, you know, I can just go to Dropbox, it's gonna have a backup in the cloud. That's not what we mean here, okay? Because Dropbox is just going to sync what you already have on your computer with what's in the cloud. But if you want to revert to a version that you had 3 days ago, or that you had, you know, that you had it working at that moment in time, there's no way to do that easily through Dropbox, okay? You can do it by renaming your files, but that's very painful. Why don't we just keep one copy around so you don't accidentally delete all of the useful files and then try to sync it properly. Okay, that's even more of an issue when you go to collaboration, right? So you're not just working with yourself, now you're working with a team member. You want to have everything synced up nicely so you're both working on the right piece of code. For example, your partner's working on the user interface, you're working on the back end to make the server talk to the client properly. You may be working on 2 different features, but later on, as we talked about continuous integration, yes, connect those 2 together, right? So we don't want to say, oh, you take the files from my UX and I'll take the files from your backend and put them together, right? You have a nicer way of putting and merging code together for that. Okay. So setup, you should have already all downloaded and installed Git. You're going to use it a lot through Orbital, and I assure you, as you go through all years of CS and even going forward, you're going to use Git all the time, okay? I have some students who do homework assignments. You're going to see later from Ben also and a couple other people that you can do your homework assignments using Git, okay? So I encourage you, as you get part of your homework assignment done, create a repo for it, put your code in there, and then you'll be able to share it with others when you're allowed to. Okay, then the next thing is connecting it to GitHub. Okay, GitHub is a separate service. It's not affiliated with Git itself, okay? It just happens to be a repository out there. It's a commercial company that provides a place for you to host repositories in the cloud, okay? But it is becoming one of the de facto standards for how people judge other developers, okay? So even though we're not, you know, really endorsing GitHub, we think it's a useful tool, especially because a lot of people in industry, when you apply for a job, they're going to find out from your resume that you have a GitHub account. They're going to check what you're doing, okay? It makes a big difference, okay? So I'll come back to that later on. You can see how some of our advisors and tutors deal with that. Okay, so how do you set up GitHub to work with your laptop? Well, it's a bit technical, okay? I won't go through it here because it's not very important, but you will need to read this if you haven't already, okay, about how to do this appropriately, okay? Basically, what you're going to do is you're going to connect your local computer, your laptop, to your GitHub account. So basically, you have to tell your laptop and GitHub that they're connected, okay? The way we do that is through a protocol called SSH keys, okay? SSH is basically just a secure way of connecting between a laptop and something in the cloud, okay? So you can talk to, for example, servers in Google, an Amazon web service, or even GitHub, okay? So what we're going to do is create, using a program called SSH keys, a series of public keys, okay? You don't have to follow along with this, just listen to what I'm saying for now, okay? You're gonna deal with this later. You're gonna connect it to your account by making a set of keys to tell GitHub that your computer is your computer, it's no one else's computer. So when I talk to GitHub, I'm providing my key to say that I'm who I am, okay? So it's the equivalent of, you know, login and password, okay? But it's automated so that when you log in, you don't have to deal with this. Okay? So basically what you're going to do is manufacture a new key for your own use. You have to type something like this in. Okay, if you have a Linux machine or a Macintosh, you can do this. Windows is slightly differently. Okay. Then you have to add it to a computer program that's within your system to tell it that you have this key. Okay. Then when you go to GitHub, you have to connect it to your GitHub account. So I'm going to show you where that is. If you go to GitHub, in the right corner of any page, you click the gear. Okay, so this is my repositories. This is me. So you go here. Okay, and you go down to SSH keys, all right, over here. Okay, and these are all the keys that are associated with my account. This is where I can work on different machines and push the code that I have into the cloud. Okay, so a couple different places. Okay, you're only going to have one for now, which will be your local laptop. You might need another one for your desktop if you're working with a desktop at home. Okay. Once you've got this set up, it becomes very easy for you to push code into the cloud and retrieve it back out. Okay. Okay. Okay, we're going to go create a repo. A repo is short for repository. It's basically like a folder, but it's a shared folder that you have in the cloud. You can think about it that way. It's like a shared drive, but it's just for copies of the same piece of software that you're working on, all of the different versions. Okay, so we're going to do that now. Okay, so I'm going to go create new. You can follow along too, all right? If you have a GitHub account, you can do this. Okay, I'm going to type new repository. Okay, and I'm going to give it a name. I don't have a good name, so I'm going to use the one that they provide, Potential Octo White. Okay, earlier I got Fuzzy Robot. I think that's a bit nicer. But anyways, okay, and I'm going to initialize this repository with a README. Okay, and GitHub only allows public repos for free. Okay, there are other services like if you want only to keep your code private, you can subscribe to another service, Atlassian's Bitbucket. Okay, so I'm gonna create a repository. Okay, and now I have a folder that's in the cloud. All right, it's already have a README file. This is a README file in a particular format. It's called Markdown, so that's why it has MD. MD is sort of like HTML, but not really. Okay, and what I can do is, let's say for this file, which I'm seeing here, I can do some edits to it. Okay, so I can edit the file. Okay, and say, for example, this is my README file. Item 1, item 2. Okay. So when I want to save this file, I have to commit it here. Okay. A commit basically says I'm going to save the local version of my project. Okay. It's a snapshot. Okay. You can think of it as a camera phone taking a picture of your software. Okay. Every time you want to take a picture so that you preserve it, you do a commit. Okay. Okay, so now I have two versions of my code. I have the one that I initialized and the new one which I added some information, right? I have now this version here. Okay, I can go back at any time and find an old snapshot of my code and work from there. Let's say this was buggy, then I can revert back and change it. Okay, now this was a change on the cloud. I want to be able to use the change that I just made on my local computer and edit it there. Okay? So what I also want to do is be able to retrieve that code that I put up, that I made in the cloud on my local laptop, and when I modify things on the laptop, be able to push it back up into the cloud, and then for my partner to grab it from the cloud, pull it back down from the cloud, and make edits to it too. Okay, so we're going to do that. Okay. So at the top page for your repository, on the sides here, there are a number of settings that you will find. Okay. So when you clone or fork a repository, it basically means that you're taking a copy of it. Okay. What I want to do is copy this repository that's up there in the server down to the local laptop that's in front of me here. Okay. So I'm going to do that by changing whatever I want here. I'm going to use SSH. Okay. So I'm going to get this SSH syntax here. Okay. I'm just going to copy it to the clipboard. And hopefully this will work. I didn't try it. Okay. Oh, prefix without the SSH. Try that again. I haven't used this for a while. Okay, good. Okay, so what I did is I went to my local laptop. Okay, you don't have to use the command line. Okay, it's just what I'm going to use for today. If those of you for Project Gemini and Apollo 11, we probably expect you to use the command line to get used to it. Okay, basically I'm just talking directly to the computer and saying, give a command that I'd like to execute. So once you have Git installed, Git is a program. I'm going to run it, and I'm going to tell it to do some commands. I'm going to clone, okay, which means just take a copy of a repository somewhere else, and then I'm going to tell the repository where that repository is. Okay, so I have to log in as Git at this computer called github.com, and then find this particular repository. Okay, once it's done, it's actually pulled that copy from the web. Okay, and now I have a copy of it here. Okay, right. So there's the file. Okay, so this is the same thing that I had up in the cloud, right? So I can add some more here if I want. Okay, and I can add, for example, other files that I might want to say. Okay, so now I have a couple of different files. Okay, well, let me change that. Let me make it into something else. Okay, and I can commit this. Okay, so we'll talk about that in a minute. So we did two things already. We did a clone. Cloning just means taking a copy of a repository that's somewhere else. Okay, so for example, this morning here in T1, Wee-sun asked you to take down a zip file, right? A zip file for gift book. All right. Now, if he wanted to collaborate with you on that, instead of asking you to download a zip file, okay, he could ask you to clone the repository for gift book. If you did that and you have the right rights to the repository, that means you can edit those files back. Okay, that means when you make changes to the giftbook app locally, you can push those changes back up into the cloud so that everyone else who downloads that file, that project will benefit from it. Okay, now we're going to add. Add means just putting more files into our shared folder. Right now, I have them on my local folder here. Okay. But I need to tell Git that those files that are locally stored are also part of the shared folder that I want up in the cloud. So I'm going to write git add index.html, okay? And I can do git status, and then it'll tell me what has changed, okay? First, I have a new file that it now knows about, okay, that I told it I want to go up into the cloud, okay? And I have another file that's been modified. Okay, so that modified file I also need to add as telling it that I want those changes that I've made to also go into the cloud. Okay, by default, any changes that you make are local to your copy only. Okay, so I'm going to add that as well. When I add type git status again, it's going to tell me both of these files are now going to be synced up. Okay, oftentimes you don't want to have to worry about which files you want to send up. You might want to send up everything. Then you can use a -a to do that. Okay. So after we do this, we do a git commit. Okay. A git commit is exactly what you saw me do earlier in the cloud, right? It's basically saying I'm going to take a snapshot of what I'm doing. Okay. Preserve it so that I can come back to the state at any time. Okay. To do that, I have to use git commit, and I'm going to add a comment, say what it is I've changed. Okay. Now, this snapshot is created. It exists only locally on my laptop. Okay. So if I want to push it back into the cloud, I have to push. Okay. Push means taking from your client and pushing it to the server, okay? You can think of it that way. I'm going to do a push. Okay, and now that code that I have has been pushed up to the cloud, okay? There's some technical details here. I'll just show you what they are. When you do a push, you have to specify usually 2 arguments unless you've already set them with defaults. Okay, one is the computer that you want to sync to, okay, the repo that you want to sync to. Just now I had pulled from GitHub, okay, and locally I had already assigned the name origin to refer to that computer, that repo, okay? So it knows where this is going to go, okay? In fact, you can have repos all over the place. They can just have different names, and you can push wherever you want, okay? And I have to also specify what's called a branch. Okay, a branch is a version of your code. It's like a snapshot as well, okay? But branches can have different tracks. They're exactly like a tree branch, okay? So you can think of master as the main branch of your code, okay? But when you want to go off to the side and say develop one feature, or your partner wants to develop another feature, typically what we do is we branch the code. We say, okay, you take a working snapshot, you go work with it on your own, and then later on, you're going to pull it back into the main master, okay? So you're going to integrate it in by pulling it back into the master branch, okay? So once I've done that, it says that I was able to do that, right? It sent it back up into the cloud. It gave it an ID, okay? And it says it was able to sync my master branch on my computer to the one in the cloud, okay? So we've covered commit now. We did it once already on the cloud, right? We've done it once locally on the laptop. We talked about pushing. Pushing is when we push the information from the local laptop, wherever you're working, back into the cloud, back into GitHub or wherever you're working. Okay? Pull is the opposite. That means I've made a change somewhere else, and I want to have that change reflected locally. So for example, let's say okay, let's say I now want to have my partner come in, and he's going to edit these files. So I'm going to pretend to be someone else for a minute. Okay? I'm going to edit these files as if I was a collaborator, okay? My partner, Wee-sun, okay, is going to edit this file. Okay, I don't like item 2. I want to replace it with something else. Okay, I'm really harping a lot on him. Okay? And I'm going to say, again, put it here, okay? What I'm doing here, when I click this commit change, okay, it's the same thing as what you saw me do over here, okay, when I did this command down here, where I said git commit, and I gave a comment. It's exactly the same. It just happens that one is a graphical user interface. Okay? So now you can see on the server it's changed. Okay? Locally, I can try to find out what's going on. Okay? So what I'm doing here is I'm saying there's a new copy of the software somewhere on the server. I want it brought down to my local laptop. Okay? So I'm doing something like Dropbox, but I'm doing it manually. I'm saying pull the changes down from the cloud, put them on my local laptop so I can work with them. Okay? All right, so as you go forward and you use Git, it's going to take a lot of practice, okay? It's not going to come naturally how to use Git, all right? But after you practice a while, you get better at it. And one of the most important things that you can do is have meaningful commit messages, okay? Meaning create comments that are useful for you to come back to. Okay, so if you use a comment like stuff, it works finally. You should have trusted me. Committed some changes. Yeah, sort of, I know that, right? Okay, all sorts of things happening. I just needed to commit it because it was late and I need to eat dinner. All right? So there are lots of bad examples. You can go check them out. How often should you commit? Basically, every time you get a feature or new part working or you get a user story satisfied, maybe you should think about committing, okay? Especially when they start to work, right? There's nothing worse than saying, oh, but it was working, but then I had to change 2 lines of code and then everything broke. I don't know what I remember doing, okay? So as soon as you get something working, go ahead and commit it. Okay, there are lots of other things that you need to know, but they are out of the scope of what we can cover in a tutorial like this. So I would say look up what branching is. It's a very important idea when you're working in a development team. All right, now you guys are first-year students going on to second year. You are only working in a team of 2, but it doesn't hurt to start learning how to use source control properly. I think all of your seniors would definitely agree with that. If you want a job and an intern in any company, then you still have to learn how to use your tools effectively. Okay? So I want to go on from there and tell you a little bit more about why Git is so useful. Okay, there's one piece of information that we didn't really cover yet, okay? And it's the fact that in users' stories, in the agile development, right? We have the notion of a user story. You remember yesterday what I was talking to you about? You have the customer give you use cases about what to do, okay? Now you can simulate what we call user stories in a number of ways, okay? Okay, so let's go to our tried and trusted thing of a Wikipedia and look at a user story. Okay. So here are a bunch of user stories that someone has made, okay, for a particular design project. Basically, they're small cards. You can use index cards to do that, okay? You just write the user story as I showed you yesterday. As a certain person, I have a certain need that I want to, in order to do something important for my application. You write any number of these. It could be 50, it could be 100, etc. You're going to arrange them and prioritize them. That's what the product manager does, if you remember. Okay? Now, we're computer scientists. You know, we're software developers. We don't want to use physical objects. Why don't we use a software system to do it? So there are a number of ways that you can do it. One way is to simulate this idea by using another software component called Trello. Okay, this is another system that you can find. You're welcome to use it. It's integrated with Slack already. Okay, so you can use it for your own teams. If you make your own team in Slack, hook it up to Trello if you'd like. Okay, and then you can see here, I've just created the same type of user stories for Giftbook as we have been talking about, right? So basically, I made a bunch of cards. All of these are things that I want to do, okay? And I can assign a person to it. I can give it a label, which we'll talk about later. Okay, I can give it a color, okay, a priority, etc. And then when I'm done with them, I can, you know, click that they're finished, and then tell you that they are finished. Okay, I can check them off. Okay, so when I check them off, I can say that one was finished, and then move it to the done pile. Okay, so when you do that, this is a very graphical version of having 3x5 cards that allow you to do user stories. Okay, this forms a sort of documentation for your project. Okay, when you go to create your project README and your log, well, not your log, your README, you can refer to a screenshot of what you did, right? These are the features that my product manager said I needed to do this sprint. This is what I already got done. And these are advanced features that we prioritize. Maybe we assign a red label to things that are of the same type. Okay? Now you can use Trello, but you can also use GitHub to do this. Okay? GitHub is a slightly harder choice to do this, but it's also much more visual, and it will help you gain more visibility when you come to apply for a job. Okay, let me show you what I mean. Okay, so we have this repo here. Okay, on the side here, there is a marker called issues. Okay, issues are where you can describe bugs about your software. Okay, you can see them all over the place. Let's take a look at any one of these other places that have that. Let's see, Bootstrap Github. Okay, Bootstrap you'll hear about in Mission Control 1, but it's also on GitHub. It's a repository. That means you can take a copy of it, okay? So if I wanted a copy, I would just do exactly what I did before. I would just copy it and then put it on my local desktop here. Okay, and then I would have a copy of all the software that's in Bootstrap. Okay, but most importantly, what you can see here are issues. This is what I want to focus on today. Okay, issues are basically it's a bug tracker. Okay, to say something's wrong with your code. You can use it sort of as a base for test-driven development. What do I mean by that? You can say I have a user story. Okay, and what I'm going to do is I'm going to enter that user story as an issue. Okay, as an issue, a bug that's in your software that you want to fix, because really you haven't written the code to satisfy the user story yet. Okay, when I write the report this way, I can have it show up on this nice board that's already prioritized. Okay, so you can see here I can sort them by a particular milestone. I can sort them by who's assigned to something, or I can assign it by label. I can say maybe I want to look at all the bugs that have to do with cascading style sheets. Okay? So when I want to create an issue, I can do exactly that. I can say, okay, user story 1. Okay, and I can say something meaningful here. As a NUS user, I want to add final past year's finals to my gift book. Okay. So now this is an issue that I can track. When I am able to satisfy this, okay, then I can do a commit that's going to make sure that this is closed. Okay, so when you do a commit, you can also associate it with one or more issues so that you can associate what you've done in your code with satisfying a user story. Okay. When you do issues, they can also assign labels to them. Okay. GitHub has also already given you some of these things, so I can say, oh, all right, this is an enhancement. Okay. And I can label it as such. Okay. Then I can go use all of the nice things that I can filter by when I go to issues to say what it is I'm going to do, right? I can say, I'm going to sort by something. I'm going to look for a specific label, okay, and work from there. I'm going to show you one other repository where this is used a lot, okay? So there's an FYP student who is working with me to create some software which you're going to be using. It's called Skylab. It's named after one of the US orbiting, the precursor of ISS, okay? And basically, it's just a Ruby on Rails, like you heard this morning from Yost, application that's going to store information about your project, README, and log, okay? So Franklin, his name is Franklin, has been using GitHub issues all the time to be able to figure out what issues to use to create the user stories and prioritize them. Okay, so you can see all the labels that he's using. He has some that are customized. So what's the priority of something? Okay, whether they're assigned to specific roles. So you guys are students, so there are some bugs that are associated with your role, some that are associated with administrators, etc. Okay. Okay, so you can see what the use of this is, because what's going to be very nice for you is if you use GitHub issues to do this, all right, your peer groups can go and look at your repository. They're going to be able to find out how much work did you do. If you use them for user stories, it's going to be very clear what your features are and whether you satisfy that or any precursors to that. Okay? Okay, as I promised you before, I said that sometimes when you commit, make changes to your code and you take a snapshot, you're claiming that this snapshot solves that problem, satisfies that user story. Okay, so you can do that. When you use Git Commit, you can say that it was closed by a particular commit. So when I click the link there, basically it's taking me back to a snapshot of this software when it was fixed, okay? Specifically telling me what did my student do or what did I do to be able to fix this particular code. Okay, so you can see what got changed. Okay, what lines of code got changed, where it got changed, which part of the Rails application layout was changed to be able to fix that bug. Okay, so this is why GitHub Issues, I think, is going to be really useful for teams just at their beginning. Okay, if you like GitHub Issues, that's fine. If you like Trello, that's also fine. This is a really nice visual interface. It doesn't have the clutter of the code, but I think there have been equal amounts of success with both. Okay, you can choose either one. The final thing that I'll mention to you is that GitHub is really, again, as I told you before, becoming a very useful platform for developers to show off how much work they've done. Okay. So imagine I am going to a career fair, not so far in the future. Okay, I have my nice CV resume printed on, nice linen paper, printed with nice font. Okay, and I submit it. I say I've done all of these development projects. How is somebody going to check that? Okay, they're not going to review your code. They don't even know what it was really created by you. Okay, but when you have a public persona, all right, a public profile, that's a little bit different. Okay, you can come back, an employer can come back to you, all right, and check what type of open source programming you've done. Okay, so when you make your repositories, in fact, your GitHub account starts to become a resume of sorts. It's a resume for a developer. Okay, so you can see, for example, here how often I've coded. You can see not much. Okay, Google would never hire me. Okay, let's take a look at some of our people. Okay, this is Ben sitting in the front. He's been answering quite a lot of questions. You can see what he's contributed to. Okay, you can see he's put some of his homework assignments also up here. So you're going to take 2104 next year. Maybe you should clone his repository so you have his answers. Okay, lab 1, 2, and 3. Okay, even for my course, there are plenty of people who posted solutions, okay, to the problems that I get. Okay, so you can get an idea of how much he's committed and what types of projects that he's committed to. Okay, we have another person. This is Jos, right? So you can see what he's been doing. Okay, and by getting a profile on GitHub and using it and always making commits to your code. Okay, then you can get an idea of what is important, okay, whether this developer is really doing work, okay, or whether someone else is not. Okay. So I would advocate to you, you now have a GitHub account, use it, okay? Use it as much as you can so that you can start to build a base. It's a resume of sorts. It's a resume for software developers. And all of you here, for at least this summer, are trying to do some type of software engineering product of your own accord. Okay? So that's all I have for you. And I hope that was useful. Again, you're going to practice this more with Git. And I think you'll learn to really like it, okay? Use it wisely. Okay, so that's all I'm going to do for that.